Hi guys, welcome back to our unit on macromolecules. Today we're going to be covering learning targets 2 and 3. Learning target number 2. As always, feel free to pause, write, and then click play to hear me explain. For this learning target, make sure you're writing it at the top of your notes. So for learning target 2, students will be able to identify reactants and products. And for those of you who had physical science last year, this should be a review. Okay, reactants and products of chemical reactions, and then we're going to show how they break down or build molecules. So learning target 2. Some key vocab and things to remember from physical science if you had that last year. First, if we have a chemical reaction, what we're referring to is when substances transform into other substances. So if we look down here at the bottom of my screen, the left-hand picture, okay, we have two different substances. We have our sodium and our chloride, and what they're doing is they're coming together to make a different substance or salt. The reactants are the substances that are going to obviously react and change. Normally, they're going to be on the left side of the arrow. So here are my reactants. They start out as just sodium and just chloride, and they react to form our products. And our products are the substances that are created from the reaction or are produced. And normally, this is going to be on the right side of the arrow. So right here, this NaCl, which is our salt, is going to be our product. That is what we are making. So we have our reactants, which are changing and making our products. So real quick, what I'll have you do is kind of go through this. What are the reactants for the following reaction? So this entire thing is a reaction. What are going to be my reactants? If you guess the stuff on the left side of the arrow, you are correct. Okay, as you can see, this arrow is going to play a big role. This is what we start with. This is our reactants, and we're going to end with this stuff. Okay, how about this one? What are the products for this following reaction? If you guessed carbon dioxide or the thing that is on the right side of the arrow, you are correct. We had carbon, we had oxygen, they combined to form carbon dioxide. So hopefully that was a quick review for most of you. Now what we're going to do is we're going to get into a little more complicated items. So the first thing we're going to talk about is dehydration synthesis. And in order to understand what this is, we need to break down those words. Okay? And so this is going to be the process of building molecules. And one way to remember that, okay, down here, dehydration, okay, think about when you are dehydrated. What is happening to you? You're going to be losing water. So whenever you see that dehydration, we are losing water. Now, synthesis is what we mean by is combination. So if I'm synthesizing something, I'm bringing it together, I'm combining it. So I'm losing water and I'm combining two molecules. Okay, so I'm going to go back up here for a second. So dehydration synthesis, we're building molecules. That's the synthesis part. Okay, two or more of our monomers are going to join to form polymers. Remember in our first learning target, we talked about monomers and polymers. And then the dehydration part comes when water is released as a byproduct. So we have dehydration, losing water, synthesis, combination. Water is going to come out and our molecules are going to join together. So right here are my reactants and here are my products, okay? Because these are at the end of the arrow. So as you can see, this molecule is joining with this molecule to make one molecule, and then we are losing our water. So dehydration, synthesis, losing water, joining molecules. You have to know what these two terms mean. You just have to know those. Okay, the opposite of that is what we call hydrolysis. This is going to be the process of breaking down molecules. It uses water to help them break down, which means water is coming in. Okay, the water molecule is added. And just so we break down this, so hydro means water. Okay, so we're not losing water, we're actually adding it this time. And lysis means to break. If you think of like Lysol or something like that, that is a cleaner that's breaking down bacteria. So hydro's water, lysis is breaking. You just have to know those two terms. Okay, so what this looks like. So we start out with one molecule, we end up with two. So that's the breaking part. Okay, we're going from 1 to 2. We're breaking that one molecule into 2. And then the hydro part is this water is coming in to break that molecule apart. So hydro and then lysis. We're breaking that molecule and making 2. Okay, that was a lot of information. As long as you understand dehydration, synthesis, and hydrolysis and what those words mean, you should be good to go. Okay, so let's do a little practice. What reaction is this? And then what is happening with our water? I'll let you take a guess first and then I'll explain. So in this scenario, okay, since the arrow is going this way, this is our reactants. How many reactants do we have on the left-hand side? Okay, nothing is bonded, so we have 2 molecules. Okay, and they are combining. As you can see, they are now bonded together here. They are combining to form 1 molecule. So we had 2, they combine to form 1. And then as you can see, our water over here is a byproduct. Okay, it's in the product side. So we're losing that water. So if I am combining molecules and losing water, what is this? If you guessed, dehydration, synthesis, you are correct. Dehydration, losing water. Synthesis, I'm taking 2 molecules, I'm combining them to form 1. Okay, how about this one? Obviously, it's going to be the other one, but think through it a little bit before you're just like, oh, it's hydrolysis. Okay, so this is our reactant side, right? Because here's our arrow, and this is our product side. How many molecules do we have on the reactant side? Okay, this means they are bonded together, so we have 1 molecule. It is breaking because as you can see, it's not combined anymore. So it's breaking into 2 molecules. And then you have to look at where is our water? Well, our water is on the reactant side, so we're adding water. So we are adding water and we are breaking a molecule. So in that case, this reaction is a hydrolysis. Adding water, breaking a molecule. You will have to identify these reactions. Okay, next I have, we're going to talk about our bond energy. So again, if you had physical science, this is a review. But our bond energy is the amount of energy needed to break a chemical bond. Okay, energy is going to be added to break a bond. So think about if you have this really big stick. If it just sits there, it's not going to break, right? You need some energy behind it. So maybe you snap it over your knee. That energy is added to break that stick. When we are forming bonds, okay, we're taking 2 molecules and we're making them into 1, that energy is going to be released. Okay, we're releasing energy when we're making bonds. A reaction at equilibrium just means that the reactants and products form at the same rate. So if you ever see two arrows like this, that just means they are at equilibrium. Okay, and so this is going to be a really important term, activation energy. And this is the amount of energy that needs to be absorbed in order to even start a chemical reaction. Okay, chemical reactions aren't happening all the time. It needs a certain amount of energy in order to start. Okay, so this is the picture that you're going to see a lot. Okay, in order for this man to get the ball to the top of the hill to roll it down, what does he have to input? He has to put in some energy, right? If you try to roll a big boulder up a hill, it's going to require some energy. So whatever that height of the hill is going to be our activation energy. That's the energy being put in order to break our reactants or combine them. Okay, so what we're going to be talking now is about endo and exothermic reactions. We're going to start with our exothermic. And so just to break down this word again, and if you've noticed in biology, we are breaking down a ton of words. Exo means out, right? It sounds like exit. Thermic means heat, okay? So heat is going out. That means that our reactants are going to have higher energies than our products, okay? So our reactants have a lot of energy, so reactants, lots of energy, and it's going to lose it. It's going out of it. Okay, the heat energy is released, and this is what the picture is going to look like. As you can see, our reactants bond energy starts here. It goes through the activation energy, and then our products energy is way down here. So we have lost this much energy. It has exited the reaction. So it is an exothermic. So if we have a system, it is losing heat, losing energy, that is going to be exothermic. Exothermic. You will have to know these pictures. Okay, some examples, real life examples. So fires, explosions, right? They're giving off heat. They're giving off energy. Cellular respiration, which we'll talk about next semester. Okay, this is where you get your energy to live. Okay, it's giving off energy. And then some animals actually give off light, and light is a form of energy. So this squid actually glows in the dark. And so it is an exothermic because it's giving off heat. It's giving off light. Okay, the opposite is going to be an endo reaction. So endo means in. Okay, I like to think N-E-N, sounds like in. Okay, endo, and then thermic again is going to mean heat. So heat is going into something. The reactants are going to have lower bond energies than the products, okay, because I'm absorbing heat. So heat is absorbed by the reaction. So let's take a look at this picture. Here's where my reactants start. I go through the activation energy, and then this is where my products end. As you can see, since my reactants are way down here, I have absorbed that much energy because over here on our dependent variable, our energy as we go up, that means more energy. Okay, so reactants are lower than my products. So the heat or the energy went in. So if I have a system and it's endothermic, it's absorbing heat. It's absorbing that heat. Some examples are going to be your photosynthesis. So when plants take in sunlight, and then also melting of ice cubes. If I have an ice cube, how does it melt? Well, it needs to absorb that heat in order to melt. Okay, also cold packs are going to be endothermic as well because it's absorbing the heat from your leg or from your wrist. Okay, what I would suggest you do is like maybe take a screenshot of this. This is really, really helpful, and just kind of a quick picture that has all the information of these. Okay, endothermic, as you can see, our products have more energy than our reactants. Exothermic, products have less energy than our reactants. You don't need to know that. Okay. All right, here's a couple of videos that you do not have to watch, but I'm going to put them in Edpuzzle just in case you're confused, and you can feel free to watch them on your own time. Okay, the last thing we're going to cover in this video is learning target 3. So learning target 3, you will be able to differentiate between solutes, solvents, and solutions. Okay, so a solution is going to be a mixture of substances. So it's going to be my end product. It's going to be the same throughout. Our solvent is a substance that's going to dissolve another substance. Water is the universal solvent. So if you ever see water as an option, it's always going to be a solvent. It's the thing doing the dissolving. And the solute is the substance that is getting dissolved. Okay, so an example I like to use is powdered mix or sugar. So here's my water, that's my solvent. Okay, the Propel is my solute. And when I mix them together and this water bottle is all yellow, that's going to be my solution. Okay, so solvent, solute, and solution. Those are a lot of S words. And so find a way that you can remember this, and then we'll also talk about it in class 2 if you're confused. Okay, so that is the basis of learning target 2 and 3. Thanks for sticking in there with me. Again, we will talk this over in class if you're confused. All right, guys, thank you.